Yeah, exactly. Yeah. Okay, here we go. I'm gonna abbreviate this. I'm gonna do a lot of shorthand here for this part. Okay, we're talking about the converse of the Pythagorean theorem, and then what that implies or what that means. So first, I'm gonna give you the original Pythagorean theorem in shorthand. The original theorem says if it's a right triangle. So if we have a right triangle, then we know that a squared plus b squared equals c squared. That's the super shorthand way of saying the Pythagorean theorem. If we got a right triangle, then blah, 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 blah. Are you cool with that? Yeah. Okay, now I'm going to ask you, what would the converse then of the statement be? If a squared plus b squared equals c squared, what does that mean then? Then it's a right triangle. So that's the super shorthand for the converse of the Pythagorean theorem. So what we're going to be doing now is we're going to be using the converse to see if a triangle is indeed a right triangle. But we can take it further than that because we can use the Pythagorean theorem to see if a triangle is either right, acute, or obtuse. So that's where we're going with this lesson. Here's the basic one. So if we're going to compare the hypotenuse, if c squared is actually equal to a squared plus b squared, then what type of a triangle do you have? Then you have a right triangle. So if c squared equals a squared plus b squared, then you've got a right triangle. Now, what if c squared is greater than a squared plus b squared? Then you have an obtuse triangle. Now, why would that be? Because the hypotenuse then would be longer than the rest of the other two sides, so you would have an obtuse. So you always compare the hypotenuse, or the bigger number, the biggest number, to the sum of the other two.
3 is not going to be acute then.
What if c squared was then less than a squared plus b squared? What would you get? Then you get acute.
No, but I thought all of them has to be, I thought for acute, all 3 of them have to be.
They would be. All 3 of them would be. All right? They'd all be less than. Okay? So, because by definition, the other two are less than 90.
Oh,
so how do we use this? Okay? All right, so here's a typical type of a problem, and this is how we use the converse of the Pythagorean theorem. You're going to be given 3 sides of a triangle, 5, 12, and 14. So the question is, do they form a right, an acute, or an obtuse triangle? Okay, well, let's see. First of all, you pick the biggest side. Which one's the biggest? So 14. All right, so since 14 is the biggest, we take 14 and we square it, and we compare this to the sum of the other two, 5 squared plus 12 squared. That's what we do. We compare it to the other ones, okay? So how much is a 14 squared? That's the biggest one. What's it? How much is it?
196.
Very good. So this is 196, okay? Well, how much is 5 squared? 25. And how much is 12 squared? 144. Now compare, add these together. What do you get?
196.
How much is 25 and 144? So now you have 196. That's bigger than what? 169. Therefore, what type of a triangle do you have? That implies we have an obtuse triangle. You guys see how this works? So here we go. We have square root of 3, square root of 4, and square root of 5. Well, we have to square all these numbers, right? So let's square all of these numbers and see what we get. What would we get if we squared all these? Yeah, we would get 3, a 4, and then a 5. Okay, what's the biggest one?
5.
Yeah, exactly, right? So we're going to compare that to the sum of the other two. So how does 5 compare? That's the question mark. How does it compare to 4 and 3? 5 is less than 7, so what does that imply that we have, you guys? We have an acute triangle. Okay? So we squared them all, turned them into the length so we can see. Find the biggest one and then compare them. Okay, we have 1, 3, square root of 10. So those are the side lengths. Given the following 3 side lengths, 1, 3, square root of 10, will the triangle form a right, an acute, or an obtuse? So first we're going to square them all. What will we get? 1, 9, and 10, right? Because the square root of 10 squared is 10. So the biggest one is 10. So how does 10 compare to the sum of the other two? Since 10 is now equal to 10, what does that imply? We have a right triangle. Yeah, the square at this little box here is the question, how do these two sides compare? Is it greater than that? Is it equal to that? Or is it less than that? Does that make sense, Ben? Yeah. So this one, we were the same thing. We're like, how does 5 compare to 4 plus 3? Well, 5 is now less than that. 10 was equal to that, so that's what we're putting in that box there. Okay, so on your whiteboards, you're given these three side lengths. Will they form a right, an acute, or an obtuse triangle? That's your task right now. All right, here's what you should have got. First, you square them all. Then you compare the biggest side to the sum of the other two sides, all right? So 20 squared is 400, 29 squared 81, or 841, 21 squared 441, and it turns out that 841 equals 841, therefore we are guaranteed to have a right triangle.